Uh-oh.
All right, so we're now going to start populating the chassis with our parts, right? So we got our octal sockets here. We got our Novel 9-pin sockets here. We got some, all different types of hardware. We got some rubber grommets for the pass-throughs of the wire from the transformers. We've got some little solder tabs here for grounds. We've got our standoffs for the board. We have some other stuff out of frame. And then we have some hardware, right? And this is just my preference. I like to use stainless steel hardware. It's very durable, doesn't rust. That's a good thing. And I like to use nylon lock nuts as much as I can, right? So a nylon lock nut basically is a nut that has a captured ring of nylon inside of this capture ring here, which becomes sort of machined by the screw itself as you're screwing it on and grips it, right? So these are very good. They allow you to disassemble things too, right? So another option obviously is to use Loctite, and I'd recommend using blue. Don't use the red stuff. It's much more difficult to remove. You have to use a lot of heat when you're getting rid of red Loctite. But blue Loctite will work in areas where a threaded, or rather a nylon insert lock nut is not available, right? So that's sort of what I like to use. So I got some kind of cool hardware here, right? So we ordered this for the amp. We got a pan head, right? Number 10 pan head screws. And these have a wide sort of shoulder on them, right? It's flat, right? It's flat bottom, wide. It's kind of shallow, Phillips head. And that's good for holding your transformers down, right? Because it has a big sort of footprint and a flat footprint for really, getting more surface area to hold the transformers in place. We've got different kinds of number 4s for depending upon what you want to use them for, different lengths. And all that good stuff. So the way I like to start is basically I'll do the stuff that's light first and add the transformers last, because obviously it's more difficult to move your chassis around and hold it at weird angles when you don't have your transformers on there already. So I could start just, with these guys, right? These look kind of big. Let's see if they even go in here. Yeah, they do. Okay, so it goes in like so. I'm going to take my screwdriver and just kind of spread it out. Make sure that they're nice and inserted correctly. All right, got this guy here is for the choke. And you just kind of squeeze them in place and then go like that, and you'll make sure that they're in nice and secure. So grommeting is fun. Do you really need grommets? There's some argument whether you do or you don't, right? It depends upon, well, first of all, let's say what the wire is that you're passing through there. Some wire is extraordinarily durable and doesn't really have much chance of being cut. But really, grommets, when when a wire is going to move constantly like this, right? Like the wire's in a socket like this or in a hole like this that's metal, and it's constantly doing this. Eventually, yes, it will wear through the jacket and potentially short against the metal that it's attached to. That's of concern in things that are constantly in motion, right? Like airplanes or cars or machinery where there's a lot of vibration and movement and things like that. But in an amplifier, the chances of, like, say, your output transformer wires or your power transformer wires actually vibrating like that are extraordinarily low to where they're going to be cutting, right? Because they're tied together, they're rigid, and the length that they are going before they pass through is so small that there really isn't a lot of movement anyway. Like if you were to go in there and kind of try wiggling your bundles of wire, they don't really move very much. So, but this is tradition and it's a prophylactic measure against shortage. So we'll go ahead, and we got them handy, so we'll use them. After putting in the grommets, I like to put in, let's put in the standoffs, right? So we got 4 standoffs here for mounting the board. I'm going to use, for this side of the chassis, for mounting rather, on the chassis I'm going to use a shorter screw. Right? Because I don't want to have interference with the screws being too long and they can't be sent home the whole way. So I'm just going to put get the Loctite going. Yeah, just put a little dab, a little drop of the Loctite in the, there we go, in the threads. I think that'll be it for the Loctite. I'm going to turn the chassis over. I'm going to grab my little screws, and then we're just going to insert them, and then we're going to screw them on, right? So that's pretty good there. So I'm just taking, obviously this is nothing you can't figure out on your own. How do you put a screw through the chassis? I'm not sure. I'm going to have to look that up on YouTube. I can drop it on the floor if I like. Right? I actually missed the wrong hole. There we go. And blue Loctite, obviously, you know, it holds very snug, but it's not going to be to the point that, you know, if you need to disassemble something, you're going to have to use a lot of heat, which could potentially damage, you know, stuff around what you're heating, right? Because heat has a way of going places where you don't want it to go necessarily all the time. Okay, got those in. All right. Next thing I'm going to do is I'm going to start putting in the sockets, right? So I have my 9 pins, so I'll start over here, right? Well, let's start here because I want to talk about this one. So I'm going to grab some stainless number 4 screws and just kind of drop them off on the floor here, right? And take out some of these nylon lock nuts, right? These are number 4 nylon insert lock nuts. And then grab my little Klein sort of nut driver, and we're going to go ahead and start inserting the screws in there, right? And then I'm going to turn it on its side here. And I'm going to take this guy, right, because we don't want to lose our screws. So I keep my fingers on the screws. All right. And just kind of start them. There we go. Grab the screwdriver. And send it home. And then we'll go over to the end one. And then I'll probably do a lot of this stuff off the camera. But I'm going to show you just a couple of things, I guess, that I'm sure a lot of you guys know or would do anyway. But it's always good to not assume facts in evidence that may not be in evidence, right? So got this one. We're going to go on the end one here too now, right? And we're going to do something there. So let me grab a couple of these, right? I'm actually at the same time, I'm looking for my little solder strip, my little tag strip. I gotta find my tag strip. I just laid it out for myself and now I can't see it. Should be here somewhere. Oh, here it is. Yeah. So I got this tag strip, right? That I'm going to build the surrogate circuit for the first preamp stage, the boost stage for the Jose onto this, right? So this is kind of a common thing that was done with things like the Dumbles and other guys. They'll just kind of mount this little guy here on the socket screw, right? So you kind of just put it there and you drop it on the floor. Yeah, you can just kind of put it there, grab your lock nut, right, thread it on. There we go. Now we can tighten these things up. And then I can build the circuit on there. I'm also going to do that for the second preamp tube, but I'm going to modify the solder tag strip a little bit. Okay, so let me just get this into a good spot. Okay, and then send it home. Make sure it's tight because I'm going to be using a ground connection there too. Okay, so that's nice and tight, right, like so. So we have our little tag there. The other thing I would want to do, well, let me put away my Loctite so it doesn't ooze all over the place. Stuff's gross. What I want to do as well is I'm going to be using a bit of shielded cable here. So I think I'm going to, for this stage, for both grids on this preamp tube, I think what I'm going to do is I'm going to mount two here as well, right? One on either side, but I'm going to cut them so that they work a little better. Grab my dikes here. So I'm just going to make them two on, or rather a tri sort of like unit, right? So I'm going to cut off the ends here on this, and then I'm going to cut off this, and this, right? So now I have like a little guy like this, right? And I can use these for pass-throughs for the shielded cable, right? Basically the center one, and I can run it through and create a ground for my shields really easily that way, right? And so I can just mount them on the side here, like so, and I can put anything I need on there, right? So that's kind of a cool little trick as well for mounting things. You could also, if you wanted to, you could use like a little solder tab like that, and you can kind of put the core of the shielded cable through and then solder the braided shield onto the tab itself, and then you have a really convenient, neat ground sort of like little setup there. Okay, so that's kind of cool. I've seen a lot of ways of doing things. Like I learned a lot from looking at like Soldano amplifiers. I think like anything, if you were to take a Soldano, like an SLO from like the 90s or whatever that Michael Soldano built, and you were to sort of study that, right? Its construction techniques and what was used to build one of those things. I think that will teach you all you need to know about making something that will survive on the road, right? I think that was, to me, the best build that was created, right? It was so meticulous, so well constructed, very durable. It really was a very roadworthy piece of work, right? So I learned a lot from, looking at what Michael Soldano did. And one of the things he would do, right, which is kind of cool, is for his grounds, I'm sure some of you know how he would do like a shielded cable, right? So, but I'll just sort of like say it, or kind of talk about it here. So let's say that this was the shielded cable, right? It's not, but let's just say it was. Mike would kind of like strip the cable back to expose a little bit of the shield, right? And then he would take bus wire, right? So let's say this was bus wire, and he would wrap it around the shield itself, right? And then solder it in place, right? And then cut it off. So you would have like a little lead for your shield that was made out of like really solid bus wire. So it looked really cool. It looked like a turret. It was very sturdy in terms of rigidity, and you could solder this shield wire to wherever you wanted, and then usually right on the pot and then on the bus wire, right? So maybe when we do this, I'll use some of that technique and show you. So that's kind of cool too. All right, so next would be, let's say, like octal sockets. There might be something there as well that you kind of can see. Now the octal sockets, you want to have obviously a ground available somewhere near the socket itself, right? So I'm just going to kind of get these in place. So that's just going to basically be one of our little solder tags, right? Those are very convenient. And then you can put on your cathode, you know, if you just want to go straight to ground from the cathodes, from pins, you know, 1 and 8 on the octal sockets to ground, or you can put in, what I like to do is put in, you know, like a 1 ohm, 1 watt resistor there, 1%, which will basically allow for a current reading of the cathode that you can use to bias an amplifier, right? Because there's a few ways you can bias a tube or measure how a tube is running, right? There's only one way to bias it. Well, maybe there's more than one way, but there's multiple ways of measuring it, right? You can, how much current is the tube dissipating, right? How much current is the tube actually kind of, you know, bringing out, putting out, so that it's within safe operational characteristics, as they say. So one way is to measure your cathode current and then, you know, multiply that times your plate voltage, right? And then you will get a reading of power in watts, right? So that's a pretty easy way of doing it. The other way, obviously, is to measure the current across the transformer from the primary to the secondary leg, right? So you would take the center tap of the output transformer and measure from there. Why do I keep dropping this nut? You measure the current from the center tap of the output transformer to each leg individually, right? And then you could get the current that's flowing through for each side of the push-pull. Now that doesn't narrow down exactly which tube is doing what, right? So you could say that both sides of the push-pull are one, you know, both tubes are running at this many milliamps in total, but you don't know, is that, you know, 20 milliamps on this one and 30 milliamps on the other tube. So that's a less, let's say, precise way, in my estimation anyway, of measuring how the tube is sort of performing. There we go. All right, so that's sort of what I'm trying to get in finality, right? Is let me see if I can put that there. That little solder tab right there that I can attach a resistor to, that 1 ohm, 1 watt, right? So that way I can measure the voltage on that basic point, right? At pins 1 and 8, I can measure the voltage there, and that will come up in a fraction. But being that there's a 100 ohm, a perfect, you know, 1%, it's got to be a good resistor. A 100 ohm resistor there, it makes the math really easy, and you end up just moving the decimal plate over 1, and then you have the cathode dissipation, right, in current, in amperage. So, and then you can multiply that times the plate voltage, and then you'll have your answers of what you're looking for the tube to operate at. So we're going to use the 1 ohm, 1 watt method here. So that's pretty good. I think that's pretty good for right now. Where are we? We're probably about almost 20 minutes. So I'll probably just go and keep going and wiring on my own so that we can kind of get this done a little bit quicker without me blabbing the whole time. And you can see it and not have to spend hours watching this. But I did also, I did add this particular hole right here for the presence control, right? Because the control panel on a Jose is, you've got your Jose master, then your bass, your middle, your treble, your volume, a volume here, and 3 inputs. And the presence is moved to the back. So that's where we stand right now. And now it's just a case of, I'll put in the rest of the sockets. I'll put in the CAN capacitors, right? They have these little clampy jobbies here, right? Which kind of sit there, and you mount your CAN capacitors on them, right? So we'll put those on right after the sockets. And then the last thing we'll put on are the transformers. And I'll put on the power transformer, the output transformer, and the choke in that order. And then we can flip it over and let it sit on its transformers, and we can start to wire the amplifier a bit, right? We'll start to wire the power supply first, right? Get that all working correctly. We'll wire the primary of the power transformer. We'll wire the secondary of the power transformer. We'll wire in you know, the switches, the lamp. We'll start to break out leads to go to the rectifier over here. All that kind of good stuff. We'll be kind of wiring up our octal sockets with the screen resistors, with the screen sort of connections, with the plate connections, all that kind of stuff. And lastly, you know, we'll put in the board and the potentiometers and all that kind of stuff. That's sort of be the last thing I do. And just go by stages and sort of test as we go along, right? It's always a good idea to test what you're doing, so when you're finished, you don't end up with a surprise like, oh my God, I hooked up the power supply wrong and all the wires are tucked, and now I got to take apart things and backtrack. So testing while you go along is always a good idea. Make sure everything's working, right? Any bad parts, incorrect wiring procedure, or a bad sort of interpretation of where a wire should go. So that's cool. All right, so okay, after a bit of screwing and bolting and all kinds of good stuff, we pretty much have a lot of the all the components really mounted on the top of the chassis. That's finished. So I'll flip it over, see what we got going on the top. So we have our power transformer, output transformer, our choke, garden of filter capacitors, our tube sockets, octals, and 9 pins. Right? We've installed our grounds, our grounding lugs, which are here, 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 and here, for our 1-on-1 watts. We have installed our grounds for the filter assemblies, right? For this is the high volt sort of network, and this will be the network for the screens. They'll be grounded here and here respectively. Got the filter cap for the preamp with its tab right here. Screen filtering right here. And main grounds for the chassis ground right here. And one thing that I did, which is maybe a little bit different than what Marshall does and what was provided for in the kit, so to speak, in the chassis, was I drilled 3 more holes to allow for a dedicated screw and nut and solder tab assembly for ground points, right? And that'll assure, you know, that you have a very solid, stable, reliable ground. Now, you know, you can, I've seen it done, Marshall does it. They mount the solder tab right here on the screw that is part of the bracket assembly for the filter cap. But I feel like it's really good, but I worry, right, that it's gonna eventually give a less than great ground, right? Because there's multiple things being sandwiched together. The fit maybe not perfect, right? And you don't want your ground to go away. Now, especially here, right? Because this is your main ground that you're going to use to ground the chassis to earth on the, the power supply for the house, the AC or the arena or the stadium or the recording studio. So you want this ground where you're going to have your IEC, your power inlet, grounded to be like the best ground, the best you can do. This most secure connection, the best solder joints, the most secure bolt, because that is really like, that's a prime safety concern. So I like to have that ground little area there, that ground very well secured. So that being said, we can pretty much start to wire up the power transformer, right? I usually do the power section first, do the primary first, move on to the secondary. I'm going to wire up all the octal sockets into their networks on both sides of the push-pull, add the screen resistors, the grid resistors, the jump leads for carrying the screens and plate to both sides. Going to add the cathode resistors. We're probably not going to do the filaments until the very end. I know Marshall, has a deal where they kind of put the filaments, and I used to do that with Blockhead, down on the chassis ground and have them sort of, one leg going here, one leg going here. I'm sort of like, I like putting it on top now the way that Fender did it. I think that's a better system. I think both legs then of the ground, right? Because you have a center tapped 6.3 supply, right? Which is connected at 2 points. And they carry noise, right? Because we're talking about unfiltered AC straight out of, the secondary of the transformer. It's not filtered. It's noisy. So you don't want to have, you don't want to add noise to your system, right? And the way that the 60 cycle hum, which could be present there, is filtered out is from the push-pull, really, like in the phase inverter, and the balance of the line itself between the two halves, right? So if you have equal amounts of wire on both sides, I think that's a better system theoretically. I just do. So I kind of prefer then to twist equal lengths of wire and just keep going down. And then I'll have at the end the same amount of wire on each leg of the push-pull with a nice tightly twisted pair, which reduces noise as well. So I think that's a cool way of doing things. I mean, the Marshall way is very traditional to kind of, lay it down on the bottom and bring it up, one leg longer than the other, but then you end up pretty much with one side being maybe 6, 8, 9 inches longer than the other side. Well, probably 6 inches, 7 inches longer than the other. Not that it's a huge deal, but we each have our own nutty ideas, and that's my nutty idea, and I'm sticking with it. All right, so I think that's good for right now. I'm going to have to rest the old tendonitis in the elbow. It's kind of flaring up a little bit from using the socket wrench or the socket driver, and holding a soldering iron. I'm not so sure that it's a good idea for the rest of the day, so I'm just going to ice my arm and rest it, and then we'll start again tomorrow. So thanks again for watching, and again, don't forget to check out 3 Monkey Solderless, right? 3monkeysolderless.com for all your cable needs for your pedal board. So thanks again. I'll see you next time.